Welcome to the Cosmic Pie Podcast, Episode 4, Season 4. I'm your host, Wayne Barkhouse.
And I'm Robert Moore.
We are broadcasting live from the campus of the University of North Dakota here in Grand Forks, North Dakota, where winter has certainly arrived.
Well, it arrived last week, but...
Well, since our last podcast, it got extremely cold for a period of time.
Yes.
In fact, it was so cold on Friday, we actually had no classes.
And the campus was closed. But that has something... I mean, minus 40 wind chills, Fahrenheit might have something.
Yeah, it was really cold, and that's only the second time since I've been here, which was in 2007, that they actually canceled university because of the extreme cold.
Right.
And it was bad.
It was bad.
If you didn't dress appropriately, you had to almost run from building to building before you'd freeze up.
Right. When I was going out in it, I got to admit, I had on my shirt, like I got right now.
Right.
I had on a hoodie, a heated vest, and a heavy coat.
You know, it's cold when I let my dogs out to pee, and they come in with one paw lifted up, and the other three are on the ground. And that's been happening, right? And they're out there and they're back as soon as they can get back, right? Poor things. Were you worried about that? I guess I have to.
You've got small dogs, so that makes it even worse for them.
Well, one's small and the other one's a little bigger, but they're not monster dogs. Well, I guess I should have winter boots for their paws or something. I do the best I clear out with snowblower in my backyard and give them a place to run and everything, of course. But yeah, it's difficult for everybody, not just humans. It's that cold. You think of the poor rabbits, right?
Oh, right.
We seen one over the weekend. He's like, you wondered a poor thing. I mean, how could it survive? But they do.
They do.
So, you know, obviously they
go
with the
on
flow.
Campus, you can see their footprints in the snow.
Yeah.
You know, so they're getting out and about.
Now, if you have any comments or questions that you'd like to ask us throughout the podcast, we do have a live chat that's running, so please feel free to use that, and we'll monitor it and reply to any questions that you may have.
Yep, relevant questions, please.
Also, we upload on the next day on Spotify. Some people like to listen there, which is kind of a little bit of a different platform, but it works just as well.
Right.
And, of course, Robert, every podcast, we got to make sure that we don't have a team of lawyers after us, so what do we got to do?
So we got to have a disclaimer. So the opinions and everything expressed herein are those of myself and Wayne, not the Department of Physics and Astrophysics, University of North Dakota in general. It's just us. So
it's just us.
Yep.
So did you want to turn that off? Is that
okay.
You? We forgot to do that.
We
Might
did.
make it easier to hear.
There
we go. That sounds better. Okay, so the first thing I wanted to do is actually give a bit of an update.
Okay.
So if we want to head to the next slide here.
Certainly.
So if you watched the podcast last week, we talked at length about the fact that the Artemis II SLS rocket was rolled out to the launch pad just a couple weeks ago, ready for its launch, hopefully at the beginning or the early part of February.
Mm-hmm.
But there are different windows of opportunities to launch. As you see there on the bottom, there is the several dates in both February, March, and then also in April.
Right.
And so hopefully one of these time periods they'll make it. Now, this is the first time humans are going to be on this rocket. It was launched a few years back. I think it was December or November of 2023 or something like that.
Something like that.
But there was no one on board, so they tested most of the systems.
What's life support?
Yeah, that's so the new thing is life support, because we'll have humans on board, 4 of them.
You know, I would have thought they would test life support before you put humans on it.
Well, they had a dummy on board.
Oh, okay.
And I don't mean someone with a low IQ. I mean an actual, like a crash test dummy, type of thing. And lucky it wasn't like a crash test, right?
Yeah.
That the actually spacecraft worked fairly well. But they put up like radiation sensors on the fake person.
Probably some G-force sensors.
All of that kind of stuff. Yeah, to monitor what the environment is like.
Right.
And that's a smart thing to do.
Absolutely.
And in fact, a new rocket for the first time, I wouldn't want to ride it. I mean, I probably wouldn't ride it the 5th time. Maybe if it was the 100th time, I'd go.
Yeah.
But anyways, no, just kidding. I would like to go.
Anyways,
they will never take me. I'm too old, and I get migraines and a little bit of claustrophobia. And,
okay.
That wouldn't be a good spot, I don't think, to go. But hey, if you give me a nice, beautiful window to look out, maybe I'll be okay.
Now, here's the thing. You know, I would strap myself into a rocket and go up. 3 million pounds of high explosives underneath me, and I'm fine with that.
All built by the lowest bidder to the government.
Absolutely. But coming back in, re-entry is where I draw the line. If I go up, I'm staying there.
Well, if you come back, you're coming back one way or the other.
Right.
Like you're gonna make it to the Earth.
Yeah.
Now you may not be in one piece, but you're gonna make it.
Yeah.
Regardless of what happens.
I
right?
think there was a movie that somebody commented to that, just get us on the ground. That part will happen pretty definitely.
No problem with that.
Yeah.
Anyway, so the SLS rocket that's going to be launched very soon, maybe in just a couple weeks from now.
Yeah.
One of the things, and what it's going to do, in case you missed the last podcast, is that the astronauts, 3 American, 1 Canadian, are going to head to the moon, go around the moon, and then come right back again. And that sort of free trajectory, if you like, free return trajectory. So you're not going to go in orbit around the moon like they did a lot in like Apollo 8 or.
I think that would have been an important step too. Is go in orbit, do a couple
It's
of orbits.
more
and then blow
riskier
out.
in a sense. You have to fire that engine to slow down to
Yeah.
go into orbit, and then you have to relight it. If it doesn't light up, you're not going to get out of lunar orbit. You're stuck there forever, essentially.
Fair.
So it is more riskier, and I don't know. This is a trade-off, right?
It is.
I don't know. The thing is, then again, all this stuff has to be tested for the next flight, Artemis III, because that's the one where humans are going to land on the moon.
And that's why I'm saying I might would
you-
have dropped into orbit.
Yeah,
for
and then
a
you're going to
time or
need
two.
everything. I don't know who made the decision and why it was made, just the free return around the moon and
It
right
just-
back again.
It just seems to me kind of like the Apollo missions. Some corners are being cut.
Well, don't
And-
forget the big announcement by John F. Kennedy. We'll get to the moon and back in this decade, right?
Right.
Not when we get there, but in the 1960s.
Yeah.
So there was a bit of a, cutting the corners
Right.
for sure in that program. In fact, as we'll mention here in a few minutes, that can lead to problems.
Can lead to problems.
Now, and the other thing is, why rush it? So you don't need to launch in February if things are not quite right. Wait till March. And if they're still not right, wait till April. And if it's still not working, wait till the next window of opportunity.
Absolutely.
And the other thing, you can almost, and they're not going to do this, you could stick in Artemis 3 as, okay, that'll be the one that we go around the moon and go into orbit and stay there for several days.
And then have
And
a
then come
fourth
back.
where they actually land.
And right, and the problem with the way things are scheduled now for Artemis 3 is the lander is not ready. I mean, no one has even tested it, at least not publicly that I'm aware of. And there are 2 companies that have bids for NASA to build a lander. One is Blue Origin, the other one is SpaceX. SpaceX, as far as we know, is going to rely on Starship. But if you look at all the launches of Starship in the past, it doesn't seem like it's ready yet.
Right.
And it will not be ready for a while to support a lunar landing mission. So I don't know what's going to happen. Either we're going to be delayed many, many years, maybe an additional 3, 4, 5 years even, or something else is going to change in the
Yeah.
meantime. So it's going to, like I said, we're in no race. And people want to make it like we're a race against other countries like China. And they want to be on the moon in 2030, so why not beat them? Well, we already beat them in 1969. Why do we keep trying to race people to the moon?
Yeah.
Right?
No, I agree.
Come on, let's just do it the right way. And there was in my opinion, negative ramifications of beating everyone to the moon, the Russians, in the 60s because we went there, did it, and that was it essentially. Came back and that was done. Let's move on to something else.
And that's essentially what the public and the government decided to do is let's move on to something else.
And it would be nice if we went there sustained fashion and sort of build up our technology, build up our experience of working on the moon and learning how to live on the moon. Maybe like Antarctica, where we have bases on the moon, have people there all of the time type of thing.
And if it hadn't have been a race, we might have gotten that.
Well, that's the thinking, right? And then eventually that would lead on to going to Mars and other places. Just a slow progression type of thing.
Right.
So anyways.
Instead of these leaps and bounds.
Exactly. And so when you're preparing to go to the moon, one of the things you don't want is something that I have currently and something that you've been fighting, Robert, if you don't mind me saying. And that's a cold.
Yeah.
You don't want to haul a cold in onboard the space capsule. So what do you do to prevent that? Well, you go into quarantine.
Yep.
So the 4 astronauts then that are potentially going to the moon in early February are in quarantine. So they go 2 weeks in quarantine, isolate themselves from everybody else so they don't pick up the flu. Nowadays, you'd worry about the measles, all kinds of stuff going on. So anyways, this is if you like, the beginning of the flight, the one that we don't really pay attention to too often. But you know they're serious when the astronauts are in quarantine, that we're getting really, really close. So
Right.
as far as NASA's concerned, I think they're ready to go.
Yeah.
It's just a matter of testing things.
That's
Yeah.
something I don't know, so I'm going to ask you. Do they go into quarantine together, or are they separated individually?
All together.
Okay.
Yep. And as you see the picture here, this is them in quarantine.
Okay.
So they are together. And they're going to be together anyways on the flight. So
Right.
it makes sense to have them together. when they
Breathing
go
each
into
other's
quarantine.
air
Yeah,
and everything.
Yeah.
Yeah.
It just makes sense.
Because I know from my days in Navy boot camp, yeah, we called it recruit crud, and because you got people from everywhere across the country in one small area, the barracks, breathing each other's air, everybody gets sick.
Yeah, and I mean that's like going back to school in some sense, right?
Right.
The incidence of cold and sickness goes up once everybody, if you like, goes to a common area from
Right.
different locations. The same thing happens. Anyway, so we're in quarantine. So there's the major hurdle to get through now is once the rocket is prepared and just a day or two prior to the first launch window, is going to do what's called a wet rehearsal, and that means they're going to fill the tanks full of fuel and liquid oxygen to get it prepped ready. Do everything and count it all the way down to T=0, except pushing the button to light the engines. So
Cool.
so you do a full dress rehearsal, with everything. And if there are no leaks, I mean that's always been an issue. That's been, ever since the space program began in like what would you say the 1950s, and even before that, if you think of Robert Goddard in the 1930s, always been an issue with plumbing leaking.
Mm-hmm.
You're dealing with super cold fluid,
Yeah.
and so things are contracting the metal.
Are just super corrosive, because one of the things you got to carry is an oxidizer. And that can be liquid oxygen, which corrodes the hell out of everything. Or it could be, what is it they use now? Hydrozine.
Hydrazine has been used.
And it's corrosive.
Yeah, so I mean, there's a lot of things you worry about it, and the shuttle had many, many problems over the years of things
Right.
leaking and launches delayed because of that, wear and tear on the vehicle,
Mm-hmm.
Things not being put together, living out some kind of a flange or an O-ring wasn't put in properly, seated, some rubber seal. I mean, we've heard it all, right?
Right.
Over the years. Anyway, so there's no guarantee that this is going to go in early February. So be very careful if you're planning a trip to Florida, which would be nice to see the launch.
Yeah.
It's my understanding it's going up at night. So
Which
it should
would
be a
be
fantastic sight.
fantastic
It'll
view,
be
yeah.
amazingly cool.
You'll
Anyways,
see it downrange for a while.
yeah, definitely. So we'll see how it goes. So all fingers crossed on that.
Yep.
Okay. Now, today is, as you all know, we're broadcasting on January the 27th. And at this time of the year, near the end of January and the 1st of February, is when NASA has its Day of Remembrance. In fact, you can see the astronauts. Now, 3 of the astronauts from the Apollo 1 are on here. This was a rehearsal also on the ground,
Mm-hmm.
where the Apollo capsule was on top of the rocket, and they were testing it, putting it through its paces to get it prepared to use it for the very first time. No one had gone up an Apollo capsule before. It was the transition between the Gemini program and the Apollo program. The 3 astronauts you see there, do you remember their names? Ed White, Roger Chaffee, and Gus Grissom?
Gus Grissom. I knew Gus.
Not personally.
No.
Okay.
I'm a bit
just
young.
know the
I'm
name.
a bit young for that.
You just know the name, right?
I know the name.
Actually, we had a student here at UND just a couple years ago who's actually a relative of that person.
Okay.
And she was telling me that I forget, like that's her like uncle or something.
Okay.
So the whole family,
Yeah.
is.
I just know that he almost wasn't on Apollo 1 because he ran into trouble with an earlier mission, Mercury. One of the Mercury missions.
Right.
And he was accused of blowing his hatch early.
Too early, and the capsule sunk.
You're right.
And they retrieved that. Do you remember a few years
Yes.
back? They actually pulled that out of the ocean.
And they did their inquiries and everything and figured out that no, it was a problem with the pyro bolts.
In fact, that led to an issue. It's good that you brought that up, because that led to an issue where the engineers thought, it's kind of risky, right? You fall in the ocean. How do you know that the big jolt of hitting? Let's say the parachute system has a little bit of a problem.
Right.
So you don't have the full, parachute surface area on your way down. So you're hitting the water a little faster than what you had planned, but not fast that's going to, kill you or something, right?
Right.
but then it might set off the bolt system, right, to blow the hatch. So in the Apollo capsule, they bolted that shut, that sucker.
Oh, okay, so it doesn't blow off.
So it doesn't
I did
blow
not
off as
know that
easy.
about it. I thought it still blew off.
No, and then the other thing is, and I guess you can tell me, is this, because you did subs in the military, right?
Yeah.
Is this like a normal practice back in that time frame, the 60s, where you'd have a pure oxygen environment, you're breathing in a sealed container?
There were questions. I know because of researching actually into the Apollo mission, I know there were questions the whole time because graphite becomes a problem in a high oxygen environment and things like that. So they were worried about fires.
But why go
Yeah.
with that? Was that something that was used like by the military? Like you go down and let's say a submersible back then, was it a pure oxygen environment?
No.
I mean, it must have been used at some point, right? Was it used like you're breathing pure oxygen as a test pilot if you're flying a high altitude aircraft?
Is at the high altitudes they were breathing in pure oxygen.
Pure oxygen.
Yeah.
So there's some leftover from that train of thought, right, by the
Right.
engineers that that's just what we do. We'll put a pure oxygen environment, not realizing that you essentially have a bomb ready to go off.
Bingo. And so now we don't do that anymore.
Yeah, we use
we also-
nitrogen, oxygen, and
This
atmosphere.
this was the first mission that they had taken the escape tower off of the top of the rocket as well.
You're kind of low on your mic, Robert.
Oh, okay. So
bring it
this
up?
is the first mission that they'd taken that escape tower with its own rocket system to lift the capsule off, and that proved to have been a problem. So
Yeah, I'll just move it right close to you because,
okay,
yeah, if you can do that a little better.
well I've got to worry about
The
mic.
wire.
The wire on the mic is a little loose,
Okay.
so
there we
it
go.
cuts off at times.
Yeah, so if you're too young to remember or hear about the history of this, so this was in 1967, January 27th, and what happened was during the dress rehearsal, they had a lot of problems that day with the Apollo 1 capsule.
Right.
A lot of communication problems. In fact, if you can look on YouTube, all the documentaries and stuff, and hear the actual recording of the astronauts speaking with the flight controllers
Yeah.
as they were trying to basically troubleshoot all the problems they were having. And there was one comment that I think it was Gus Grissom that made a comment, or it could have been Ed White. How are we going to get to the moon if we can't talk between 2 or 3 buildings? Like
Yes.
they were pretty upset at the time.
He was mad.
They were there hours and hours and hours, right? And they were like ready to end it, right? Let's
Right.
get out of here. And what had happened in the investigation afterwards is that some spark had occurred, an electrical spark.
Mm-hmm.
And some of the wiring wasn't flame-proof, fireproof,
Right.
as it could have been. And that ignited a fire in the pure oxygen environment. And they couldn't get out.
Yeah.
And that's because the hatch was sealed a lot more secured because of what happened,
Yes.
in prior space flights.
And the bottom line is there were a lot of little mistakes. There were enough going wrong, as you just mentioned, that they really should have just scrubbed the mission and got everybody out
Yeah,
and
scrub the
redone
test.
capsule.
Yeah.
And they pressed forward with it. And an extra accident happened, one that you couldn't recover from.
And of course, hindsight's always 20/20, right? So anybody looks at this today, say, "Well, of course you'd never use a pure oxygen environment. What were you thinking, right?" I mean, because if you have a spark, it's gonna, burn like crazy in that type of environment. But you don't always think about those kind of things, right? I mean, we're human beings,
Right.
so we're prone to error. So we have a lot of people double checking, quadruple checking everything that we do to try to minimize that sort of thing. But mistakes do happen, and this unfortunately occurred. Now, the other astronauts that are listed here are actually individuals that died on a space mission itself. So Apollo 1 was something that happened on the ground during a test. The Space Shuttle Challenger was the first in-air sort of accident that occurred, and the Columbia was the other one. So the Challenger actually blew up on takeoff. We're going to go in detail of it for those who don't really know the history a lot. That happened 40 years ago tomorrow.
Yeah.
So it's been 40 years. And then the other one, which was on February the 1st, 2003, was the Columbia that broke up on reentry. And so
Right.
the story behind that one is the fact that there was foam being shedded off the external tank. And that's happened probably on every flight of the shuttle
Yeah.
to one degree or the other. And in this particular flight, a large piece of the phone had separated from the external tank while they were still a little bit in the air.
Mm-hmm.
And that phone accelerated, of course, and then hit the leading edge of the wing, which is made of carbon-carbon material. And at the time, and you can see in the slow frame movie that they have, right, the high-speed movie, watch it, a frame-by-frame basis, you can see the foam disintegrating as it hit the wing. It just shattered into all kinds of, particles and stuff.
Yep.
But at the time, NASA didn't realize that that could actually do some major damage to the leading edge of the wing itself.
Which, again, how could you not? The speeds it's going.
Well, the interesting thing about it is after they happened, they took a piece of the leading edge of the wing, right?
Mm-hmm.
That they know what they have it, parts of it and stuff, and they set it up on a special test bed where they launched a piece of the phone at about the same speed it was traveling when it hit the leading edge, and it made a nice big old hole, and it looks like the size of a watermelon.
Right.
So that would prove that yes, it's a dangerous time in the flight where that can occur, right?
Yes.
So at the time when it had happened, when the wing got struck by phone, they actually told the astronauts that this was the case. And they told them not to worry. And if I remember right, it was like a 2-week flight.
Mm-hmm.
So in the meantime, the engineers were talking amongst themselves, like, should we do something? Like, what can we do? Well, let's take one of our spy satellites that's in an orbit higher than the shuttle. The shuttle was always a low Earth orbiting vehicle.
Yes. Yep.
Let's take one of the spy satellites and try to get a picture of the wing surface and see if we can see if there's any holes. Now, at the time, the Canadarm, and I don't think it was even on the flight because this is where they had like Skylab type of stuff in the cargo bay taking up all the room. If, somebody can correct me, but I don't think there was a shuttle arm on there. Even then, it couldn't reach over the shuttle. It didn't have the extension piece that they later put on to do the surveying underneath for tile damage or on the leading edges or even at the nose.
In fact, this mission is what led to that.
It led to that.
Case.
So the only good sort of view you could get then was from a satellite. And Mission Control debated with the NASA authorities, and they decided, no, let's not put in a request to the military to get an image. We're okay.
I didn't know that either.
Now,
Jeez.
yeah, and so you might ask, well, what would I have done? Well, you fly a particular flight profile when you re-enter, right? You just don't come in straight, right? It's very complicated. The problem is the shuttle is like a giant glider.
Mm-hmm.
None of the engines are going to work, to do anything when you're in the atmosphere of the Earth, right? You have some minor thrusters and stuff, but they only operate efficiently in space, in the vacuum. Once you get in Earth's atmosphere, they can't move the shuttle very well at all. And so you're relying on the flight surfaces, the wings and the rudder and everything else, and to be able to glide that to this specific location. Now, of course, everything's computerized, and you're well trained, so things should work out and should be fine. But if you come in, if you know that you have a gaping hole in the leading edge of the wing, maybe the thought was afterwards, of course, that you come in on a slightly different profile. Your angle of attack, as they say, would be different.
Right.
To try to minimize plasma, right, the heated gas that you're going to experience when you're entering the Earth's atmosphere at a high rate of speed and therefore lots of friction, that you could minimize the plasma getting into the wing itself. Now, inside the wing, you had hydraulic lines, all these kind of things. In fact, that's when they knew there was a problem. When Mission Control, the sensors were telling them they lost different things, different temperature sensors, pressure sensors in the wing.
Yeah.
That was the commonality, right, from different systems.
Yeah.
Like from the tire pressure, they weren't reading the tire pressure anymore. Well, the sensor got burnt through, right, the connection to the computer. All of these things are all in that one area from the wing itself. But it's only, of course, afterwards you kind of put all that together. At first, you're extremely puzzled, like, what's going on, right? The tire pressure sensor has nothing to deal. Now we just lost the hydraulics. Like, communication is out, all of this kind of stuff.
Yeah.
And so it was all tied together. So unfortunately, the Columbia, and the first evidence they had, and I watched this live on TV, the first evidence that they had of a problem is when somebody in Dallas on the local TV station was watching the reentry of the Columbia coming down in multiple pieces of fireball.
Right.
And NASA looked on TV and said, I think we're done here, like it's over. Lock the doors.
Yeah.
Because we're going to have a major investigation. It's not coming back, right? So that was what happened with Columbia. But for the Challenger itself, of course, that was totally different. And because it is 40 years since the Challenger exploded during takeoff, during launch, during its flight, I thought we'd go into it a little bit of detail. Because 40 years, probably most of our viewing audience are probably weren't even born at that time. Boy, do I feel old.
Yeah.
And I was in front of the TV watching it that day in January of 86. So
I was just in class.
I had a view of it. I used to pay attention a lot to the space program, so
Right.
I was a space nerd and watching this stuff in detail. So yes, I was watching it and to try to, to see the flight. And of course, this flight was very interesting from the point of view of PR because it was the first time that NASA was going to send up a teacher in space, a private citizen, not a test pilot,
Not a test pilot,
not somebody who joined the astronaut corps on purpose, right?
Right.
Maybe you were a science or a medical doctor or whatever, but you were trained to be an astronaut. There was somebody who was brought in from a different profession and trained specifically to go up on this flight, and this was STS-51L. So here's a picture of the crew. So the individuals, trying to remember them all. So we had Mike Smith, who was the pilot. He's the one on the front, on the far left. Then we have the commander of the flight, Dick Scobie. And then on the far right, we have Ron McNair. So we have the Ron McNair program throughout the country, including here at the University of North Dakota. So that was a great tribute to Ron McNair. In the back row, on the far left, we have Ellison Onizuka from Hawaii. Actually, when I was in Hawaii several years ago, I went to the cemetery where his remains are buried.
Okay.
And they have a nice memorial set up for him. The person on to the right of them is Krista McCullough, the teacher from Concord, New Hampshire. That was a bad sort of time because, their whole school is in the gym watching the liftoff and seeing it happen.
I can't imagine what that would have
Oh,
been.
that was terrible. The person to the right of her is Gregory Jarvis. So he was and also another non-professional astronaut. Hughes Aircraft Company he worked for. So he was going up as part of the experimental payload they had in the cargo bay.
Yeah.
So, businesses could actually say, okay, you're an expert on this stuff. We'll send you up on the shuttle, to do the experiment and the testing and things. It was a good way of doing things, right?
Yeah.
Why train an astronaut to do this when you already know it in detail?
Right.
And
Agreed.
And you can fix things probably on the spot. And then finally on the far right, as we're viewing it, Judy Resnick. So she was in the first corps of female astronauts that NASA had selected. That would have been in late 1970s. That included Sally Ride, the first female American in space, and so on. And all selected, of course, for the shuttle program. Now, this flight, as it occurred in 1986, you might remember, Robert, that this is just a month or so away or a few weeks away from close approach of Comet Halley to the sun on its return. And every 76 years it fly by closest point to the sun, and this happened in the winter of 1986. So on board were instrumentation, space telescopes that were designed to image Halley and study it and so on and so forth.
Yeah.
So that was part of the payload that they were taking up at the time. But most of the attention was focused on the Teacher in Space program. This is something that was initiated first. I think it was Ronald Reagan that started this program. So this was in 86. Ronald Reagan came into power in January of 81.
Yeah. The whole point was, bottom line, to try to show that citizens, normal people, could go into space.
In fact, the first call-up was teachers, and there were literally thousands and thousands of teachers that applied to be the first one to go up. And the idea is you would teach lessons from space.
Right.
So you can imagine that, different science experiments you could do in the weightless environment, with the geography type of looking down at the Earth and all this kind of stuff. This would be amazing, that kind of. Now, this did happen later on in the shuttle program, but of course, this is when it was supposed to happen initially.
Right.
And the other idea is this whole Citizen in Space program actually took on a life of its own. We were going to send up the first journalist, I should say, in space, the first artist, a painter,
Okay.
for example.
I didn't hear about that.
or maybe someone to write poems or music. This whole thing, you get into the arts part of humanity. to open up space for everybody. That's the idea. I mean, the shuttle was initially sold as routine access to space. A shuttle would land. 2 weeks later, it would be turned around, refitted, refurbished, and up it would go again. So every 2 weeks there would be a shuttle launch, but then you have multiple shuttles.
Right.
So every couple days there's a shuttle launch. From Florida. In fact, they were expanded outwards to California. There was a shuttle launch, a launch complex that was built. There was never any shuttle ever launched because the military was interested in this. Let's have our own shuttle, which they were building, to launch from the Vandenberg Air Force Base in California. And the beauty of that is you can put them in polar orbits, you see? So you can have spy satellites that would cover every square inch of the Earth, which is good for looking down on people and keeping an eye on them from the military perspective. So all of this stuff, there was grandiose ideas of doing all this. But, people who were astronauts in the program, the hardcore astronauts from the test pilot days, they always said that unless we had, 200 or 300 flights on the space shuttle, it's never going to be routine.
Yes.
In fact, the Challenger launch was the 25th launch of the shuttle.
Right.
And according to them, it was far from routine.
And that gets into a point. I got to admit, and I'm kind of ashamed to admit this, but, I was a junior in high school. Shuttles didn't blow up, folks. So me and my buddies, we weren't in an assembly watching it launch or anything like this. And all of a sudden it started circulating from other students that it had blown up. Well, we thought they were kidding because shuttles don't blow up. And it wasn't until a teacher dropped on us that we were like, wait, this really happened? So it was a different era back then. Shuttles don't blow up.
I mean, you just got to look at the press coverage, right? I remember the first shuttle launch in April of 1981, John Young and Robert Krypton, STS-1.
Right.
So they go up, all kinds of fanfare. Of course, the shuttle was never launched before, unlike the SLS rocket, unmanned it. When it went up the first time, there were people on board.
Right.
Talk about risky.
Yes.
You got to hand it to people like that who are willing to hang their life on the line like that, right? It's just, when you think of. But they were pretty confident that everything should work out, that, they go through the process of watching how the systems are developed. In fact, when you think of the shuttle, it had quite a history of developmental issues.
Yes, it did.
It had a lot of issues.
We should have known better.
I mean, one of the reasons for it is because it was made to be reusable. Mm-hmm. And when the shuttle program was first, if you liked, told to Congress, mm-hmm. It's like, look, let's make everything reusable, and that would that would drive the cost down dramatically. So for every pound of weight that you'd put in space, it only costs like $100. Probably back in Apollo days, I don't know exactly, $100,000 or something, right?
Right.
Very routine, cheap access to space. That was the selling point.
That was the selling point.
So in order to reach that, you have to make everything reusable. Mm-hmm. So in the standard way of doing things up to that time, you use the rocket once.
Right.
You don't use it again. So when you design a rocket engine, you don't have to use it 20, 30, 50 times. You use it only once. It has to survive however many minutes you want it to survive, plus the redundancy on top of that. Mm-hmm. And so there were a lot of development problems with the space shuttle main engines. The media would be writing stories. This would be in the late 70s, where every so often the main engines are blowing up on the test downs down in the southern U.S., right?
Yeah, Michoud. I remember hearing those things roaring because I lived in Slidell, Louisiana at the time, and Michoud was just a few miles away.
Pure, liquid hydrogen, liquid oxygen type
mm-hmm.
of fuel and oxidizer for them. But a lot of it was tied into the redundancy. These things had to be reusable, high-performance engines. Anytime you're developing stuff, we use the term rocket science, right? Oh, it's not like it's rocket science. Why can't you do this? But it's not really rocket science. That's a misnomer. It should be rocket engineering.
Yes.
But it doesn't sound as good.
Right.
Right? It's not really science in that sense. It's engineering. It's the practical use of science.
Rocket scientists, we often talk about how it's not music theory.
Yes, right. So anyways, the engineering itself can be extremely complicated, and you need to work through all the issues. I mean, just look at even today, SpaceX with the Starship. I mean, they have top-of-the-line engineers working for that company.
And on that point, I'll mention, people often miss the point that you want things to go wrong on the test missions so that you can fix them so that they don't go wrong when it really counts.
Exactly. And so even though the media lost interest quite rapidly, after probably around the time we hit the 5th or 6th shuttle flight, it was like snooze fest for a lot of people. Oh, it's going up again. Well, by the time you hit the 25th flight, the only exciting thing on this mission was the fact you were sending up a teacher in space.
Yep.
And the media got excited, and they followed Krista McAuliffe throughout her training, going through all the routine and getting ready to go up on the shuttle and all these kind of things. So that was the high point, really, of the preparation for the mission itself. Now, of course, what happened was about roughly 73 seconds after launch, the shuttle itself exploded. And at that time, I remember listening to the media coverage. Like I said, I watched it live and knew about the shuttle in detail because I was very interested in the space program, still am. And I knew that the moment when I saw this, and this is the view that we've seen on TV broadcasts, I knew right away they were done. Like there's no way.
There's no
and people said,
recovery.
okay, when is the parachutes going to pop out? So they come down on the rescue, this and that. And eventually there was a parachute that people saw. And in fact, if you watch the live coverage back then, and you can get it if you search for it right on YouTube and stuff. And I remember seeing it. It was the nose cone of one of the solid rocket boosters, which had a parachute on it.
Yeah.
It has nothing to do with the space shuttle itself. Right, that had no rescue sort of equipment hooked up to it.
It didn't.
There was no way to bail out.
It was supposed to detach from the rocket boosters and glide back in.
There was no way. And if detached at this point, it's still in the atmosphere, traveling at hundreds and hundreds of miles an hour. The aerodynamics is like taking a pane of glass in a windstorm and going right full sideways, face on to the wind. Right, I mean, you're going to have a lot of force there versus edge on.
Right.
And so as soon as the shuttle detached from the external tank, it just broke apart aerodynamically, right?
Yep.
There was no saving it there. And what had happened, as we'll get to in a few minutes here, is that one of the solid rocket boosters leaked. And eventually it's the joint, if you like, or the attachment to the side of the external tank, the bottom one had left go. And the whole solid rocket booster swung outwards because that's the way the thrust vector was at the time, and we'll see images of that in a second. And the nose part of the solid rocket booster went into the external tank and ruptured it. Well, now you have liquid hydrogen and liquid oxygen all mixed together in the same volume or same area with also flame around, spark, ignition.
Yeah.
And the whole thing, then external tank blew up, forcing the shuttle itself with the people, the humans on board, away from the explosion. But as soon as it went sideways in the air, it just all broke apart anyways.
Yeah.
So there's no way that they could have bailed out of it. There was just no means. It was no escape tower on the top like they had in the Saturn V and the Apollo program time before that as well. None of that existed for the shuttle.
Right.
In fact, if you look carefully, the suits they were wearing at launch were not even pressure suits. They were these thin sort of blue uniforms that you would wear, like you'd see.
I've forgotten about that.
That you would
You're
see
right.
people on like Star Trek wearing, these kind of things, right? So that's how safe they thought it was at this point, right, where things are so routine.
Yeah.
So there was no way you could survive this. There was no way, right? There's absolutely nothing was built in. In fact, when the shuttle did return, they had a pole that extended out through, once you open up the hatch, you could extend this pole and you put like a hook around the pole and you jump out with parachutes. You had the full pressure suit then and so on. So if you had time and you could level the shuttle, let's say you're on your way down on reentry and there was a problem, right? You weren't going to land, right? Survive. Maybe the landing gear pops up just before you land, so it wasn't that. Let's say there's some issue or something. Then you might have time to get people off. And it would still take a while, like several minutes. So they tried to do something, I guess, to help, right? But there's not a lot you could do. But back in there, in the time when the Challenger was launched, we didn't have any of those safeguards at all built into it. Now, obviously afterwards, there was a big investigation that was done. At the time when the Challenger was launched, in January of '86, it was extremely cold back in Florida. In fact, this is an image taken during the night before the launch. And you can see icicles hanging everywhere. Part of the reason is that the water sound suppression system that they use, so just before the engines light up, they pump a lot of water into the flame trenches to suppress the bounce back of the shock wave to hit the space shuttle. In fact, I remember during the first shuttle launch with John Young and Robert Krypton, afterwards, they reported that they didn't have enough water flowing into the flame trenches, and they actually bent some of the structure on the shuttle because of the bounce of the shock wave hitting the launch pad and then back up against the shuttle itself.
Right.
So they had to increase the volume flow, the rate of flow of water into the flame
To
trenches.
damp that shock wave.
Yeah, for future shuttle launches.
Yeah.
So there's water around, and this stuff will freeze in pipes. What do you do? You know, what's one of the things we're told to do if you're in an environment where you have no heat source and you don't want your water in your pipes to freeze? You let the water run.
Let the water run.
So they leave the water run. Well, where does the water go? It goes all over the launch structure, and you can see the icicles hanging everywhere.
Yeah.
So there was a problem. The problem would be when this launch, and you got all that tremendous energy shaking everything, these icicles, pieces of ice, are breaking off. And how do you know they won't land on the shuttle and cause damage to the heat shield, right? The tiles. In fact, the tiles was another major sore point in terms of the engineering, the development that had to be done before the first shuttle launch. Is these tiles are extremely fragile. In fact, you could take them, put them in an oven, heat them up to 1,000 degrees or more, and then you could literally grab the corners of the tiles, they're made like a cube shape, and pick them up without burning yourself. They dissipated the heat so rapidly because of the specialized
know that.
material.
Okay.
But they're extremely fragile. You could take a hammer and shatter them.
Okay.
So you have ice falling on them.
They're
You
going to
could
shatter.
break. You can break the tiles, and in that case, you'd have problem on reentry. So they were very worried about it. And what they should have done in hindsight, and hindsight's always 20/20, obviously,
Yep.
is they should have waited and launched on a warmer time.
Yeah.
And we'll get into that here in a second. Now, immediately after launch, there was an indication of problems. Here's a still image that was taken literally seconds after ignition. The SRBs are already have lit off. The main engines are going before the SRBs. And you see that puff of black smoke against the side of one of the solid rocket boosters, sort of to the right of the middle of the frame. That's a bad sign.
That's a bad thing.
And what that was the combustion of one or more of the O-rings.
Yeah.
And we're going to show you a sort of a cutaway diagram of what the joints look like. So gets into this issue. Okay, so for political reasons, really, my opinion, right? We did a disclaimer, so this is my personal opinion. In order to keep everybody happy in the country, when you have a major program like the shuttle program, you would like to have vendors, people building things all over the United States.
Right.
So you have some manufacturer in Ohio, you have somebody in California, you have a company in Washington, you have somebody in Texas, and so on and so forth, so that everybody relies on the shuttle program.
Yeah.
And therefore you can pressure your politicians to keep the fund flowing, to keep the program going. If not, you fear the loss of jobs.
Right.
If all the jobs were in Florida, right, then you'd
who
have
cares except Florida?
Yeah, you'd have 49 other states complaining about the space program maybe and ultimately voting to cancel it at some point. Who knows, right?
Right.
Florida would get all the money. It made a lot of sense that if you're building solid rocket boosters, two of them, one on either side of the external tank, these solid rocket boosters would be built right next to the launch pad because they are long cylinders and you could build them in one piece, manufacture as one separate unit.
Good point.
But these solid rocket boosters were built in Utah. Morton Thiokol was the company at the time. And to get them from Utah to Florida, you had to ship them by rail. Well, if you had a big, long, solid rocket booster, you couldn't ship them by rail. They were too long. So how do you make them shippable? By train? You cut them up in segments. Okay, fine. Then you get the segments to the Kennedy Space Center. Then what do? Then you got to stack them. You have to attach them. Well, how do you attach them? You have to come up with some way of joining the two segments so when they ignite, that rocket, exhaust doesn't blow out the side where they're attached.
Right.
And you do this through a combination of O-rings. And this ultimately, it turns out, was the problem in this case. In fact, where you see this puff of smoke is where one of those segments are joined together, clearly showing that the O-rings have failed the moment of launch.
Yeah. Unfortunately, by the time this happened, there's nothing you can do.
Robert,
Those
when
rockets are
you
killed.
light the solid rocket boosters, you hang on till they finish burning.
Yes.
There is no way to detach them in flight as they're halfway through consuming their fuel and oxidizing.
Yep.
In fact, if you did manage to detach them, they were unguided. They could fly anywhere. In fact, they could fly right into your ship. And essentially, that's essentially what happened, right? They
Yeah.
went into the external tank, the one that had the problem, the one you see here on the right side.
Yeah.
So that was a major issue. Now, to confirm that, here is another image taken of the shuttle as it's heading uphill. And you can clearly see the blowtorch-like effect of the leaky joint on that solid rocket booster on the right one. And that's just burning away, an extremely high temperature of thousands of degrees, of course. And that's pointed, close to where the attachment strut is that attaches the solid rocket booster to the external tank.
So it melted it.
There's one in that area, and there's one much further up further, right, towards the nose cone of the solid rocket booster. And eventually that gave way, and then the whole thing swung in, the nose part, into the external tank, rupturing it, and then ultimately causing all happening, just in a fraction of a second,
yeah.
right, when it occurred. So there's many evidence to show that leaking solid rocket booster. Here's another image of it as well. I mean, one of the things that you do during these type of launches of any rocket is you have multiple cameras running at high speed from multiple locations to get, in case something happens, whether it's unmanned or not, so hopefully you can piece together what was the root cause of the failure, fix it, and then try again. And so it's not unusual that you would have many cameras that were filming the shuttle during launch, and we have that with all our rockets nowadays as well. Now, when this happened, of course, one of the things you worry about is, what is the reaction? So here's a still from the Mission Control in Houston, Manned Spacecraft Center, Johnson Spacecraft Center, of a time when it happened. You can see the main flight controller there, the director of the flight, mission director, so that's Jay Green. You don't see Capcom, he's kind of on the other side, away, like opposite of where the picture is being taken. And you can see another individual staring at the monitor, watching the leftover, the explosion.
Yeah.
And clearly you know what's happened. And there's a famous book that was written, Loss of Downlink, which means immediately all the data is cut off when the thing exploded. So there's no updating of any of the computers and mission control, of course. You lost your connection. And you can just, use visual cues to see what happened. It was clear at the time to everybody that the whole thing exploded. Why it exploded, of course, that's something else, right?
Yeah.
Now, if we go to the next image, always a lot of this details come out. Eventually, there was a presidential commission that Ronald Reagan established investigating the Challenger disaster. And here's one of the sort of zoomed in image of the debris that occurred during the explosion. And the piece that's, if you like, pointed out here is actually the forward fuselage. Inside there, that's where the astronauts were.
Yeah.
Which tells us that now the fuselage itself, if you like, the cabin where the astronauts were in, and there was 4 upstairs and 3 downstairs, 7 astronauts all together on board the flight. That fuselage is isolated from the rest of the shuttle body when it was manufactured.
Yep.
And the reason for it is you want to damp down the noise and vibrations during launch. So you make it it's like almost like independent suspension, this kind of stuff. So it had more strength to survive the explosion, the tearing apart of the shuttle, than some of the other pieces, if you like. So it's not unusual that the fuselage would be together, as you see here.
Yeah.
And so what would happen to the debris? Well, it continues to move upwards, right? Reaches an apogee.
Until air resistance stops
Yeah,
it.
slows it down and reaches your high point, and then down you come. Well, there's no parachute. There's nothing, no rocket boosters on here that could slow you down. So you impact the water at several hundred miles per hour.
Yeah.
And you can't survive that. It's just too hard of an impact. And if any of you who jump off the high board at a swimming pool know,
Yeah.
and that's only a few feet up,
Right.
and this is coming from several miles up, obviously, that if you hit, that hurts if you're not positioning your body in the right shape. And so if you just hitting at such a high speed, I mean, it's game over. There's nothing you can do about it. Do you want to speak about what was released eventually to the public about during the
No,
descent?
I really don't,
But for sake of
Eventually
completeness,
they've
it's been 40 years, so let's say it.
eventually they've released the fact that they had telemetry data coming in still, didn't they? I thought they did have to.
No, everything was cut. Do you want me to
In that
say
case,
it?
then there was a high probability that there were people that survived the explosion and were aware the whole way down.
Well, as soon as that happened, the first thing that Mission Control said, are there any recovery forces in the area? Well, number one, what are you going to recover?
Right.
Number two, nobody would go in the area because the pieces were raining down for many minutes.
Yeah.
So it was unsafe. You get something fall on top of you, right? You don't want that. Because don't forget, the stuff kept going upwards till it reached the apogee, and then it all came back down again. And some of it has aerodynamic surfaces, so it can fall at different rates,
Right.
Like think of a leaf falling versus a rock falling, for example. Now, what happens is they recovered the fuselage. They recovered the remains.
Yeah.
And in the fuselage, they discovered that several of the emergency oxygen tanks were triggered, and people, and these were situated behind the commander and the pilot. Yeah. So somebody in the top, where the cockpit is, where the controls are, somebody sitting behind them, which would have been Ron McNair and Judy Resnick, one or both had to activate the oxygen supply that would feed oxygen to both the commander, Dick Scobie, and the pilot, Mike Smith. So somebody had to be alive inside that fuselage on the way down to activate those oxygen tanks. And some of the oxygen was depleted, like it was being used, like people were breathing.
Yeah.
So if there were one or more astronauts alive on the way down, and there's no way of slowing the craft down, they would have died on impact. It's just too hard of an impact.
Yeah.
So that's unfortunately the news that came out eventually. Now, at the time, of course, the big press was about the first teacher in space, but of course, this just stopped everything. We had talked about this in the past, Robert, that at the time, Voyager 2 was flying by Uranus. So it was the first time we had a close-up view. So believe it or not, most of the space media, the people that follow these launches and what's going on in the spacecraft, they were actually over in California at the Jet Propulsion Laboratory listening to the press conferences of the latest, greatest discoveries that are being made by Voyager 2 at Uranus. Mm-hmm. And they watched this happen on TV, and of course they had to hightail it to the East Coast to do the reporting, do their jobs, essentially. So, of course, everybody, reported this. This made worldwide news, as it would. And for many, many, many weeks, people were covering what was going on, what was happening with the investigation, why did this happen, and so on and so forth.
How did this happen?
And you can see the cover of Time magazine also reporting. It was a major, major, major news. Now, of the day of the accident, Ronald Reagan was the president of the United States at that point. Then he put together a presidential committee to investigate to see why it happened. And of course, he had to come on and do a delivery from the White House to talk to people about this. And, it was a major, major sore point. In fact, it's still a sore point today.
Right.
It's almost as asking you, not in my day, not in your day, like, where were you when JFK was assassinated, right?
Right.
Probably in our day would be, where were you when 9/11 happened? 9/11, right? A terrorist attack in New York and the Pentagon. And this is like falls there in history, right? The annals of history, this sort of major event that happened for the United States and everybody really around the world. And so the presidential committee was formed, and here's an image of them. Some important people to note there is you have in the front row the first female astronaut, American astronaut, Sally Ride. You have the first man to land on the moon, to walk on the moon, Neil Armstrong is there. Yeah. In the back row, who's second from the left,
wow,
you also have Richard Feynman.
I didn't realize he was part of it.
Yeah, and Richard Feynman will say a little bit more about him here in a second. And so you had all the big wigs. There are some military guys there as well. So anyone who was big, the guy who was running it was William Rogers. So he was a big political guy, of course, who did a lot of important work for several administrations, not just the Reagan administration. So it effectively became known as the Rogers Commission to investigate to interview people to find out what happened.
As such, usually are named. So.
Yeah. Now, at the beginning, when you watch this stuff, people have written countless books about this disaster and so on. NASA, of course, is different people who are in the decision-making tree are brought in front, asked different things. They brought in all their technical stuff, and they said, okay, here's the shuttle, this is how it works, and blah, 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 all of that kind of thing, right? And people at the committee finally realized that it was something actually pretty simple that happened. In fact, this was a demonstration that Richard Feynman actually had done, but he was prodded into doing this. One of the, I won't say the name, but one of the members of the committee had Richard Feynman over to his house for a Sunday evening.
Okay.
And while he was over there, and he said this on camera, so it's not like it's made up, right? This is not
Right.
hearsay. There's actually words from the individual's mouth. He took Richard Feynman out into his garage where he had some classic cars.
Mm-hmm.
And these classic cars, old engines, had the old, carburetors on them. And
Oh, okay, yeah.
And he
which
said,
have rubber
and he
O-rings.
said to Richard, Richard, when sometimes when the weather's very cold and I start my cars, I notice the carburetors leak because of the gasket. The rubber gasket is not as flexible in the cold weather as it is in the summer.
Mm-hmm.
I wonder if that is related to our problem. And Richard Feynman, being a very famous theoretical physicist, he worked on the Manhattan Project to build the first atomic bomb. He won the Nobel Prize in Physics for something that we call quantum electrodynamics, which is really explaining how electricity, how light and electrons interact and how everything like that works, for example. And Richard, afterwards, he even stated this, that he knew he was set up by this guy.
Okay.
Because he had so much clout, Richard Feynman, the great physicist, that what he said, regardless of what it was, everybody would listen. And what Richard Feynman did is he took a piece of the O-ring that NASA had brought in, some of the material, and during a break in the commission, during the hearings, he took a piece of the O-ring, stuck it in a glass of ice water that he had on his table, and left it there. And he took that vise, the U-clamp that you see there, and he clamped it down on the O-ring.
And it
Right?
shattered?
No, he clamped it down on the O-ring, left it in that ice water until the hearing got started from the break. And then when it was his turn to speak, he undid the clamp. And he said, I essentially, to paraphrase him, I dipped this in water at 32 degrees Fahrenheit for several seconds or several minutes. And he said, when I open it up, the C-clamp, and let it go, it doesn't go back, expand to its original shape. That the cold weather has an effect on the O-rings. And that's exactly what happened. In fact, some of the material that was recovered includes part of the right solid rocket booster. And what you're seeing here is some of that recovered debris, and you can see where the flame had shot out the side, near where the joints, where the segments put together by these O-rings. And clearly it was burning through the metal like a torch, like we've seen in those images.
So I'm gathering then that it probably compressed as the rocket ignited and started forcing up. And then once it was in the air, it opened up, but the O-ring didn't expand back.
Exactly. These
Okay.
things are made to be flexible to fill in those gaps, right?
Right.
In fact, and this is the really hard thing to figure in your mind when you think about all this, this is a plot that was done by Brigham Young University in Idaho. And in Idaho, so there's a campus of BYU in Idaho. They did a study on statistical analysis, and they used the Challenger disaster as one of their case examples. And what you're seeing here on the vertical axis is the probability of at least one of the O-rings failing. There are two O-rings in the original design of the joint.
Okay.
And what you see on the horizontal axis, on the bottom axis, is the outside temperature in Fahrenheit. The individual black dots that you see here represent previous launches before Challenger. Remember, there were 24 of them. The
Yeah.
Challenger was the 25th. And notice the failure of one O-ring occurred for 6 launches prior to Challenger. Those are the 6 data points at the top, where it's at the probability of failing of 1 because they failed. So when they recovered the solid rocket boosters, part of the reusability, and you examine, refurbish them, bring them back to ship them back to Utah to get them refurbished and ultimately send them up again.
Yeah.
When they open up the segments, they found that these O-rings, there was damage done to them.
And nobody said anything?
People
This is
said
news to
engineers
me.
were tracking all this stuff. And notice the correspondence with temperature here. The bottom part, you see a lot of black dots sort of around 65 degrees Fahrenheit and warmer, up past 80. Those in which you had no failure of the O-rings in a prior launch. Notice the overlap here. Even in warm temperatures, we do see some failure in the O-rings, but we clearly see it, you see, at the colder temperature. In fact, with sophisticated statistical analysis, sophisticated in the sense from the ordinary person who doesn't know a lot about statistics, but this is kind of mundane stuff now if you're a statistician, right? You know how to run the statistics.
If you're in big data.
Right, if you're a big data person. You can look at that graph, and that graph gives you the probability of failure as a function of temperature. Now, the temperature at launch was estimated to be about 31 degrees Fahrenheit. Robert, if you go by that curve and you believe it, that it's true, actually reflects reality, what is the probability of a failure of an O-ring when you launch at 31 degrees Fahrenheit?
1 or 100%.
100% failure. 100% failure. So the engineers, there's a big story on this, of course, people who know the details of it.
Yeah.
The engineers said, from Morton Thiokol, said, we don't want you to launch, it's too cold. In fact, they had conferences throughout the night by telephone trying to convince people to launch. There are individuals that were named, which I won't name, who are part of the shuttle program that were pressuring Morton Thiokol to sign the waiver that they should launch, right? Not to say the launch should be canceled. The shuttle was going through a period where many of these launches were canceled. People were getting upset over that, right? The government wasn't happy about it. The higher ups in the program weren't happy about it, and so on. In fact, there is some of the language that was recorded and reported to the Presidential Commission was an individual said, something to the effect of, "My God, Thiokol, when do you want us to launch? In April?" In other words, we gave you a contract to build a solid rocket booster so they would be able to function at even cold temperatures as well as warm temperatures in Florida. Are you saying your product
can't meet the
requirements? Yeah. Is that what you're telling us? That's the pressure the company was under, the ones who responsible for the construction of the solid rocket boosters. The engineers who were working with it directly at Morton Thiokol knew that if you launch at a cold temperature, the chance of the O-ring failure happening was very high.
Right.
Very high. And if you go to the next slide, you'll see both the original field joint design and the one that was redesigned after the Challenger. So the one on the left is the old design. What you have here is a primary O-ring and a secondary O-ring. That's it. That's your protection. If one fails, then the other one is getting the direct force on it, the heat. And if that secondary one fails, then it can leak through the joint and go outside. In fact, there were shuttle launches where the shuttle made it, luckily, and both O-rings had failed. Both of them. That, you would assume by 2020 hindsight, would be enough to stop the program and redesign the joint. And they did that. The shuttle was grounded for a little over 2 years, and they come up with the new joint you see on the right. That has 3 O-rings. And the joint is built and more robust, so it can survive a failure of 1 or more O-rings and still enough there in the design, if you like, to prevent what happened during the Challenger. All you had to do was shut it down for maybe a year, redesign the joint, and you're good to go. Mm-hmm. And of course, that didn't happen. Whether it's pressure, scheduling, all that kind of stuff. In fact, how the program was run is used as a way of team and management and circles to learn. This is things you should not do, right? Mm-hmm. Allow things to creep forward where you're having reports of problems and failures.
You shut it down.
And you shut it down. You don't let it, snowball, if you like, to get to the point where you have a catastrophic failure in all of this. Yeah. So it was totally preventable. It was human error, this whole thing. It didn't need to happen. And unfortunately, that also happened several years later with the Columbia, that we had reports of damage, of foam coming off the external tank. NASA should have studied that, put on the better way to have the foam attached to the external tank. In fact, that's why the shuttle was retired eventually. They had to use it to put the space station together, is because the design was faulty. Right. There was a flaw. And eventually it bit you in certain body part.
Well,
see?
As I tried to explain to people, because I would think I was teaching high school at the time of the second one, the 2003 one. Yes, I would have been. And being the physics teacher, they were coming to me and asking, how could this happen? And one of the things I point out at that one was, how long had these things been flying? 20 some odd years. how many of you keep a car for 20 years? And how much more complicated is the space shuttle? The bottom line is they should have been retired long before 2003.
Now, of course, after the Challenger disaster, not only were the solid rocket fuel joints redesigned, but they looked at everything, top to bottom. And they made hundreds and hundreds and hundreds of changes, some minor, some major, to try to improve the reliability and to make it safer. And eventually, the shuttle was launched again. So this was the launch of the Discovery. This happened on the 29th of September, 1988. So a little over about 2.5 years, roughly,
2.5 years
since the Challenger explosion. And everything was going fine after that moment until, of course, 2003, when they had the Columbia. And then the decision was made, let's retire this thing as soon as possible. And that's all ties into why we're waiting for Artemis II to go up, because that is the new system. You know, we had SpaceX step in there and fill the gap a little bit with the Dragon capsule to get to the space station. Before that, we relied on Russia to take us up in their capsules. But the SLS was in the American government way of, if you like, replacing the space shuttle. And then thinking about what should we really do in the space program.
And we didn't know what to do for a long time.
Do astronauts really need to put their lives in jeopardy to launch a satellite?
Right.
Or should we just do that on unmanned rockets? And that's the choice we made, is no, let's put up as much as we can on unmanned rockets, because you're never going to get 100% safe.
Right.
Just like how long have we been flying airplanes, and how many airplane flights are there around the world daily? That number is huge.
Huge.
And yet we still have plane crashes. We still have failures. So it's never going to be 100%, reliable all the time.
Right.
There are accidents that's going to happen, and we need to learn from those accidents
and
make
do better
sure
so that accident
will
doesn't
never happen again.
Yeah.
So, but anyways, we're at the end of our podcast. If you're interested in engineering, if you're interested in the space program, if you're interested in trying to write about this stuff, become a journalist, report on the space program, or anything else, remember,
write a book about history of it.
NASA thought it was worthwhile, and we do too, of putting up the average person in space, whether you're an artist, whether you're a school teacher, you name it. So one way you can go to those professions, of course, is to get education at a higher learning institution like the University of North Dakota.
Absolutely.
Now come here. It's a beautiful campus. There's lots of activity. There's lots of new buildings going up all the time. We have a beautiful new STEM building that's going up. In fact, as soon as the weather gets a little better here, I'm sure they're going to work on it like gangbusters. So we're going to have this. We have this beautiful campus already, and it's only going to get more so into the future. So please check us out. If you can't come here in person, of course, we have lots of online courses and programs that you can get from the comfort of your home, even if that home is in Tahiti. And if it is, don't forget to send your invitation to Robert and I.
Right.
Especially in January. We would love to go to Tahiti.
We'd love to visit you.
Now, we always leave you with a quote or a saying or something like that at the end of every podcast. And by the way, the next podcast, 1 week from today, that's February the 3rd. February already, 3rd. Robert?
Yeah.
Well, that's good. Get out of the winter, get into that spring. We love spring.
I guess.
But we don't want to rush the time.
Okay, okay. I'll go with that another time.
Now, I decided that I'm going to read a poem today at the end of this podcast. And this poem, just a small bit of it, was actually stated by Ronald Reagan during his address to the nation after the Challenger explosion. And I'm going to read the whole sort of poem in this case. Many of you probably have heard of this. It was actually written by John McGee Jr. He actually was born in China to American missionary parents, American by birth because of that. He joined, as you know, the United States did not go into the Second World War until after Pearl Harbor.
Right.
And that's in 1941, December 1941. But prior to that time, Great Britain, the UK, and the Commonwealth, including Canada, was involved in the war. And as soon as Germany went into Poland, that's when World War II started in 1939.
Yep.
So Canada, where I'm from initially, and I am a naturalized citizen, so don't go after me, please. Canada joined with Britain, in war against Germany at the time. And so what happened was John McGee actually went to Canada to learn how to fly.
Oh,
So
Okay.
he joined the Royal Canadian Air Force in 1940.
Nice.
And so he could go over to the fight for England during World War before the United States got involved. Unfortunately, he was shot down over the English Channel in 1941 as part of helping Britain, of course, defend
Right.
against the German aircraft. And this poem was actually written 3 months before his death.
Oh. Okay.
And and a lot of the astronauts know about this poem. In fact, Gene Cernan mentioned on one documentary that I watched that, this is kind of the way that he thought how to describe the feeling of being an astronaut. Because for some people, it's very difficult to put the emotion into words for others to share. So here's the poem. The poem is titled High Flight.
Okay.
And it goes like this. Oh, I have slipped the surly bonds of earth and danced the skies on laughter-silvered wings. Sunward I've climbed and joined the tumbling mirth of sun-split clouds, and done 100 things you have not dreamed of, wheeled and soared and swung high in the sunlit silence. Hovering there, I've chased the shouting wind along, and flung my either craft through footless halls of air. Up, up, the long, delirious, burning blue, I've topped the windswept heights with easy grace, where never lark or even eagle flew. And while the silent lifting mine I've trod, the high untrespassed sanctity of space, put out my hand and touched the face of God.
Nice.
If you like this podcast, please give us a thumbs up. Please subscribe if you haven't subscribed, and we'll see you next week.
We'll see you next time,
Thank
folks.
you.
Have a good one.